Hi, this is Mr. Max. So I'm doing gradients of curves. This is one of my last videos on the series of graphs or functions. All right. So the objective that you need to be able to know is that you're supposed to be able to estimate the gradient of a curve. All right. This is just an estimation. So our answer would be in a certain range, depending obviously on your smoothness of your curve and so on. All right. So we're going to be drawing tangents, which means essentially you are still dealing with a question on graph of functions, and then you just have to answer questions based on that. Right, so let us bring in a function here. By its nature, it looks as a cubic function. Right, so as you can see here, this line AB that I just brought in here, that line represents, okay, it represents the tangent. Now what a tangent line is, it just touches the curve at one specific point. It doesn't cut through it, it just touches the curve. So that's the tangent line AB, all right? And if you bring in further, you will realize that, as I said, AB is a tangent line, okay? And then also that C there is also a tangent line because it just touches the curve, all right? And then also you're talking here about D is a tangent, but either point here is not a tangent because it cuts through the curve, all right? And also this GF or FG is not because it cuts through. Right, now what the tangent of a line also bring in to view is what we refer to as the gradient. So when you can see in this particular line AB here, when the line slopes in this way, the gradient is positive. And at C here, the gradient is 0. Okay? And here, the gradient is negative, as you can see from D to E. And then it goes up again, but although this one here is not a gradient, it's not a tangent line. All right, so we're going to look at functions, and then you're going to be asked to draw a gradient line or a tangent, okay, which is essentially the gradient, and then you ask questions pertaining to that. Right, so the three things to remember, as I said, the gradient of a curve is the same as the tangent, okay, straight line. Now, what the difference between what is straight line, its gradient is constant, okay, its gradient doesn't change. So whatever the value, whatever values you are choosing, suppose you are choosing perhaps a point somewhere there and a point somewhere here, all right, the gradient will always be the same, delta y, delta x. All right, that means the exchange in y was changed in x. The gradient will be the same, so this gradient is constant. But the gradient of a curve changes, all right, depending on the particular point that you are referring to. So it varies, all right. So that is one of the things that we are dealing with when working with curves. You will always be asked to find the gradient. But one of the things that they also do for your level is they tell you find the gradient of a graph at a point, say where x equals to 2 or x equal to some number, and then you find and you draw that particular tangent line, okay, and that will just be an estimation. Like for example here, that is just an estimation, that line P there, all right, or that at point P, that tangent there, it's just an estimation. Its gradient won't be the same as these other points, for example. It varies, it changes, okay. All right, so let me just do an example on this quickly. So the example I have here, it says that you're supposed to draw a graph. All right, now from previous work on graphs, you would know that this is a parabola. All right, and in order for you to draw a graph, I would suggest that you complete a table first of values of x between -2 and 3, that is the domain. Okay, so if I have done it already here, so I get the corresponding y values, and you plug in -2 into the function. And remember, don't make a mistake here. Okay, so when you have y equals to negative, you must in your bracket put that value there. I often see a lot of students, they are making a mistake when it comes to substituting that point in. When x is -2, you must then plug in -2, as you can see, and then you're going to get an output of -4. All right, and what you can do then is with your calculator, you don't have to use the table function on your calculator, you just take off these values and replace them then with the next value of x that you're supposed to use. So you're going to say now when x is -1, okay, -1, obviously then you get 0 and so on. So this is how these values, all right, have been calculated. Okay, so I'm getting my domain values of x from -2 to 3. That is why my table is -2, -1, 0, 1, 2, and 3. Input into the function to get the output. Okay, right. So now I have a complete table, which means I can actually sketch. First, I always like to sketch so I can know exactly what is the highest value of y, what is the lowest value of y, what is the x values it's given. So my graph is going to be from -2 to 3, all right, and also -4 to 4 for the values of y. So -4 is the lowest and the highest is about 2. Okay, right. So now I have already done my graph. Okay, so if you can look, for example, for a point. So for example, if you were to look for this particular point here, all right, so when it's -2, then all the way up to here, you can see I get my corresponding value. Okay, so the points are plotted. Now I can answer any question that they want me to find. Right, now they are saying we are supposed to find the gradient of the graph at the point where x is equal to -0.5. So -0.5, I bring it in, it's going to be somewhere here, halfway between 0 and -1. Okay, so that's the point B I'm referring to. That's the gradient. I mean, that's the point B. So I'm going to draw a line that just touches that. All right, so if I draw that line, okay, I use that point and I will just use another point here. It's totally up to you which points you use. All right, so I like to use the point that I'm given, okay, like the point here where the x is -0.5, so the corresponding value there is going to be yes, you have it correct. So x is -0, the corresponding value there is 1.3. Okay, so one little small square here represents, you got it, 0.2. So 0.2, 0.4, 0.6, 0.81. So it's 1.2. So that's about 1.3. All right, so now I have got a point here, okay, and another point that I took from the line here, -1.2, which is where this arrow is at A, okay, and 0. So here I can actually now calculate the gradient. And again, you will see that the gradient is just an estimate. All right, gradient is delta y over delta x. That means you take exchange in y, take two y values like I did, 1.3 minus 0, and then you take two x values and you get an answer, and you expect the gradient to be positive because the line slopes in that direction. All right, so let's continue with the very same question. So they want us to find now at a point 0.5, where x is 0.5. So that is somewhere all the way up here. Now what you can see, that happens to be the turning point. So that is actually a horizontal line. And if you remember from previous videos that I have done, you will realize that the gradient of a horizontal line is equal to 0. Okay, so that gradient of line CD is equal to 0. So let's bring in another point, 1.5. So 1.5 is somewhere here between 1 and 2. It's about here. So expect the line to have a negative gradient. Okay, so you then take your x value as well as your y value. So my x value here is again about 1.4, 1.5 there, 1.5, sorry, and then the y is 1.3. Okay, right, so I have got that point 1.5, 1.3, and then I bring in my line, and I will have another point that I drew with your line, and you can read off that value of x is 3 and -1.6. So now I have 2 points, and I can actually calculate my gradient. So my gradient is approximately -1.9 when I do that. All right, I find the two y values, the difference between the two y values, and then also it's very important that you rather put them in brackets so that you don't get confused. Okay, and then I said the gradient should be negative because of the steepness of that line, the slope of that line there. Okay. All right, so let's do a question. All right, so I've got 2 questions that I have done. So it's based upon some practical situations. This one says when X CDs, a certain amount of CDs are sold, the profit, which is represented by a Y, made by the person who produced them, is given by this particular equation. Y equals to A in brackets X minus 10 and 90 minus X. They say that A is a constant value, all right, and the values of X are between 0 and 90. Now, it is also known, and this is very important why they give us this information, and I put this in green and I put this in blue here, because this is going to allow us, if I sub for x, remember the x represents the cities, I have a 30 everywhere, I have the x, and a y substitute 600, that's going to allow me to calculate the value of a, okay? So, as you can see, with the blue is where my x's are, and the 600 here represents the value of y, which is the profit. Okay, now, so you can actually solve this particular equation and then you can find the value of a. So our value of a is nothing but a half or 0.5. Okay, right, so now they want us to complete a table. So they are giving us a table and it's based on this particular equation here. Right, so we've got P. Now we already know what the output is once x is equal to 30. So I expect that to be 600, okay? So when it's 90, then I will substitute into my equation everywhere where there's an x, I will substitute with 90. So if I do the 30, just to make sure, we have the 600. Now when you do the 90, all right, where you have x going to be 90, everywhere you have an x, you replace it now with your 90, all right? So you have got 90 here for the value of x, and you substitute then, all right? Here you substitute with the 90 and here you substitute with the 90, and that is how you find the values of y in that particular case. In this particular case here, you had the value of p, that's 30 here, and I substitute 30 here, but remember this one we already did, and I know what my output will be, okay? So you must make sure your table is complete and everything is in order. So now they want us to draw this on a sheet of graph paper. So we are going to use a scale where we use 1 centimeter must represent 10 units on the x-axis, and 1 centimeter must represent 100 units on the y-axis, and then we draw the graph, okay? So let me bring my table, my completed table back here. All right, and I know, again, as I said, if I look at my scale, the x-axis, the highest value here is 800. So 800 is going to be the highest value. All right, so it will not hurt if my graph can go up to 850 or even 900. And the lowest one is 450. Minus 450. And remember, on the y-axis, then they want 1 centimeter must be 100 units. So it's going to be 100, 200, 300, and then obviously 100, negative 100, negative 200, and so on. Okay, and x value, obviously it's given in the table, so we know that the values of x should be from 0 to 90. So I expect something to be like this, okay, that I'm going to plot, and I expect my graphs to be more or less taking that particular shape. So it's very important that you use this so you can exactly know what is it that you expect, or how do you expect your function to look like. All right, so let me bring my table. I just cut it in two for space. So I have my graph here, my x-axis, y-axis. You can see I labeled them. All right, and now for me, the only thing that is necessary is for me to plot the points. Okay, so when x is 0, negative 450, somewhere halfway here between negative 400 and 500, negative 500. And when x is 10 and 0, it's supposed to be on the x-axis, as you can see that red dot. Then 20 and 350, 20, 350, halfway here between 300 and 400, and you plot it. Okay, don't make your dots too thick, otherwise they become like a circle, and then it has a diameter, and then it's very difficult because some of these points are not exactly whole number points. Okay, so 30 and 600, so 3600, this one is straightforward, it's exactly a whole number point. 40 and 750, 60 and 750, so 40, 750, and 50, 800, that's the highest point there, so this graph is a maximum. And 60 and 750, it comes down again. 80, 350, as you can see, and 90, 0. So these are the points, I've plotted them, and now you can actually draw your graph. Okay, so you join them and it should be a smooth curve like that. Now they are saying, now by drawing a tangent, you're supposed to find the gradient of the graph at the point where x is equal to 30. So where x is equal to 30 here, we're supposed to then draw a gradient, a tangent there. And then we find the gradient of that particular line there. Okay, so if you look at that point here, it's 3600. So I'm going to use that point and another point when I extend my line. All right, so when I extend my line, remember a gradient, the tangent should just touch that point, and I have another point that I can work with. So I'm using the point 42, all the way up there, the point 42, 820. Again, it's very important that you know how much does one little small block represent here. All right. So if you're a little bit confused, you should know that you have got 100. Okay, and then you are dividing, because you have got 5 little blocks, by 5. So each little block on the y-axis represents, on the y-axis it represents 20 units. Okay, and then each block on the x-axis, that will be 10 divided by 5. Then on the x-axis, each block then represent obviously 2 units. So you must make sure. So I'm here at 42 all the way, as you can see. That gives me 42 all the way there. And then I read that answer there. That gives me 820, because it's 810, 820, 840, more or less. Okay, so it's more or less, it's going to be something approximately. That's why we are estimating the gradient. Okay, right. So now that I have that, I have my line, and I can actually calculate. I have my 2 points. Okay, I can calculate my gradient. Delta y over delta x, exchange in y over exchange in x. Take 2 y values, subtract them from each other. Like I say, 820 minus 600 and 42 minus 30. Now it's very important that I could have started with 600. Then I would have said 600 minus 820 for the y, and then because I started with a 600, I must then start with 30 minus 42. All right, you will still end up getting the same answer, and you can see how the line slopes, the gradient is positive. So more or less, now what we expect is an answer in the range between 18 and 22. Okay, so if you have got an answer in that particular range, when you do this question, you are going to get the mark, because this is just an estimation. Okay, so not everybody is going to have the very same gradient. It depends on the smoothness of your curve and everything and so on. But that we expect the gradient, because it's an estimate, to be anywhere in that range. That is when x is equal to 30. Right, so I'm going to bring that graph back here. So now they are asking me some real life questions. They say find the number of CDs that can be sold to make a maximum profit. Now, a maximum profit simply means, and if you remember from quadratic functions, that the maximum of a quadratic function, because here the quadratic function, the value, remember quadratic functions, they take the form, if you can still remember, ax squared, okay, plus bx plus c, all right, equals to, all right, that's y. So what we are saying is that a, which is this one here, if it's less than 0, your graph is going to take that particular shape. So if that a is greater than 0, then your graph will open up. So when it is here, then like in this particular case, we are having a maximum. Okay, in this particular case here, we have a minimum. So what this question is asking us, the maximum value, the maximum profit is coming, you find it by the output. The y value gives you the output. So it is essentially that particular turning point, but the y value of that turning point, okay, that we are looking at. All right, so the maximum value therefore is the turning point of the graph, and that should be where you have got 50 CDs. So when you read down, you realize then you have got 50 CDs when you read down, because what you have under is the CDs and here is the profit. Okay, so they want the number of CDs, so it has to be 50. Okay, I hope that is something that you have got to understand. Right, so then there is another part to this particular question. It says find the profit per CD. Okay, so we're going to use our answer that we have there. So we know that 800 CDs or 800 profit, you get 50 CDs. So 50 CDs you get a profit, or you make a profit of 800. So when you divide the two, then you know what is your profit per CD. You make $16 per CD. That's your profit. Okay, now they're asking us here to draw a line here of y equals 12x, the gradient is 12, tells us something. Okay, right, so I'm going to bring a table of values. So I'm going to use values between 0 and 70. All right, I didn't want to use 80 and 90 because it would be a bit out for my given range here, okay, or the y values. So what you do is you just need 2 points in any way to draw a graph or a straight line. So I plotted the point 0, 0 here at the origin, and 70, 840 all the way up there, and I draw that line, and now I have got my function y equals to 2x. Now, they want us, the second part, to find the number of CDs sold such that the profit per CD is $12. Okay, so when you have here the profit, if X is 1, then you have $12. So we expect a value of X here to be obviously more. Okay, so the number of CDs sold. So it basically is just where the graphs are intersecting. Okay, when the graphs are intersecting, then the first instance is going to be somewhere here between 10 and 20. Okay, which is about, mine says 15, 14, so I'll accept that. All right, again, one little block here represents 2 units. Okay, all right, and this one here, it's about 62 CDs. So 15 CDs and 62 CDs is the correct answer. This is the number of CDs that you sell, that you make a profit of $12 per CD. Okay. The second question, something very similar. You have got a wall here, okay, and then you have an enclosure. So a farmer, he makes that rectangular enclosure here for his animals. He keeps them here, and the enclosure here has a width of X meters, and the area is A square meters. Okay, so you're not exactly told, so that's X, and the area is A square meters. So they are giving us a formula here. The formula is represented by A for the area, 72x minus 2x squared. Again, you'll notice that if you were to draw this particular function, it's going to be a function like this here because of this negative value here. Okay, so completing it is same and similar like the one I did before. All right, so first we're going to complete the table. So we've got values here of P and Q and R. Again, you just punch in value of P when it's 15. Everywhere you have an X, you get an output of 630. When I do the same for the 20 here for Q, I get 640, and the last one is 35, and I get 70. So now I've got all my values here, all right, and I will be ready then to plot them if they are giving me a particular scale I'm supposed to work with. So on this part, they are saying you're supposed to use graph paper, and you must use a scale of 2 centimeters to represent 5 units on the x-axis and 2 centimeters to represent 100 units on the y-axis. And then you draw the graph of A equals to 72x minus 2x squared for values of x between 0 and 35. So if I bring my table back again, like what I like to do, I have got my completed values. So from my table, I can know, okay, from the x scale, I know that my scale must be from 0 to 35. Then the highest y value here, looking at my values of y, 640. The lowest one, 0. Okay, so I expect a graph to be in that particular region, and then I will use my correct scale. So it's going to be a function that's going something like that because of the value of A here, which is -2. Okay, so I expect to have something like this. Now I know what is the region I must use on my graph paper. Right, so let me bring my table back and also my graph. Okay, so I have done everything that I have. So the only thing left for me here is to plot the points. Okay, 0.0 is the origin, the 0.5. And now you also need to understand something before maybe you start just plotting. Okay, all right. So you know that what does one little square here represent? So one little block here represents nothing but 10 units. So this is, in order for me to find 5 and 310, it will be somewhere around there. Okay, so that is what I expect for that particular question. All right, so also maybe you need to do the same for you to find what does one little block here represent. Now remember, it's 5 and there are 10 between them. All right, so one little block here represents nothing but 0.5. So always better for you to be able to determine those scales before you do anything. Okay, so that you don't plot and make a mistake in plotting and so on. All right, so if I continue, when x is 10, y is 520, as you can see from my table. All right, and x is 15, y is 630, all the way up there. When x is 20, y is 640, and x is 25, you get 550 for y. X is 30 here, you get 360, and 35 gives you 70. And then you go ahead and you draw that particular function. Please remember, freehand drawing. Okay, you can even label your function. So now you're ready to answer whatever questions they ask you. So they're going to ask you to find the value of x when a is 450. Now this is very easy. All right, so you just draw that line. So this is your A, okay, and that's your 450. So you draw the line of y equals to 450, and then you read down the values of x. Okay, now remember I said one little block here represents a half. All right, so if you need to be able to determine, so this is 5, that is 6 there, 7, so this is 8. Can you see that? So that is the next one, obviously. So x is equal to 8, that's what I'm expecting, but we will take any answer between 7.5 and 8.5. The next one here, again, remember, this is 25, 26, 27, 28. So I expect about 28 there, okay? That is what I'm expecting. All right, again, if you don't get 28, but you get anything in the region between 27.5 and 28.5, it will be accepted, okay? That is how that particular question is done. So we will accept your answer as long as it is within the range, okay? Right, so they are saying here, you are supposed to use your graph to find the maximum area of the enclosure. Maximum, the keyword there is maximum. All right, so maximum, you know the maximum. This graph has a maximum, it's all the way up there, okay? Where the gradient is equal to 0, that's the maximum. Okay, so what do you do? Simply the turning point, but we are looking for the maximum area of the enclosure. Okay, so that has to be the 650 that we are talking about. All right, because this one here is your area, it represents your area. All right, and obviously on this one you have got your x values. Right, so that is how this particular question is done. You use your graph to be able to do that. There's just one last question that we have to look at pertaining to this particular graph. Right, also if you had anything in the region of 641 to 660, they would also accept that. The only reason you will be out is your curve is not as smooth as mine, okay? Right, so they are saying here that each animal must have at least 12 square meters for grazing. Now remember, you have got that enclosure, all right? So that in that enclosure, we expect to have, you want to know the greatest number of animals that the farmer can keep, all right? And the area that you have there is 500 square meters. So it's nothing but 500 square meters, all right? Then you'd simply divide that by 12 square meters in order for you to find the answer. All right, it's about 41. So you can't say 41.6 because there is no 0.6 animal, okay, unless you're saying babies, but that doesn't make sense. All right, so 41 animals can be kept, okay, and then they will share that space, and that is the area that they can graze. Okay, so that is how you address this particular question. I hope that you have picked up on a few pointers and have learned something. And I guess if there is something that is not clear to you, you pause the video or you rewind and then you check again and try also to do similar questions in order for you to understand this.